Hello everyone, welcome to 12.4 where today we will talk about multiplying and dividing rational numbers. Remember that when we talked about multiplying and dividing integers just last chapter, we had a set of rules that we used. And when we multiply and divide rational numbers, we use the same rules for signs as you would use for integers. So if you remember, let's just recap those rules. Oops, sorry, my screen kind of shot up there. The rules for integers that we use are when you are multiplying two numbers with the same sign, you get a positive product or quotient. Right, product if you're multiplying, quotient if you're dividing. So that would be like a negative times a negative. We have two of the same sign, or a positive times a positive. We know that when we multiply two positives, we obviously get another positive, but it's the same with two negatives. When you multiply two numbers with the same sign, you get a positive answer. Now, when you have different signs, you get a negative product or quotient. So you get, for example, if we were to take a negative times a positive, we would result in a negative answer, or a positive times a negative. That order could be reversed. We'll still get a negative answer. Okay, so we're using those same exact rules for multiplying and dividing rational numbers as we used for integers. Same exact rules. All right, let's try a few examples together here with multiplying and dividing and see if those make sense, and we'll go from there. The first example says dividing rational numbers. Find negative 5 1/5 divided by 2 1/3. So the first thing that I'm going to do is, as I'm going to estimate, I always love to do this just to make sure that my answer is reasonable. And I'm also going to determine, is my sign going to be a positive or a negative sign? I'm going to do that right away before I do any math, just to give myself a ballpark answer. So if I'm trying to determine what sign this is, I have a negative divided by a positive. That would be a case where I have different signs, so I know I'm going to have a negative answer. Okay, and then for my estimate, let's see, the 5 1/5 is about 5, divided by 2 1/3 is about 2. Okay, how many times does 2 go into 5? 2 whole times, and there's 1 left over. So it's close to 2.5, and it should be close to negative 2.5. Our final answer should be, let's actually do some math now to see if that's the case and if that works out. I'm going to erase this just so I have some little bit more room to work here. All right, so when I divide fractions, first I'm going to change them to improper fractions. So 5 times 5 is 25, plus 1 is 26. So this would be the same as negative 26/5 divided by 2 times 3 is 6 plus 1 is 7. So 7/3. And then when I divide fractions, I'm going to use that handy dandy acronym that I like, which is KFF. Keep the first fraction the same. Flip division to multiplication, and flop the second fraction to its reciprocal. Okay, and then I can look and see, is there any simplifying that I can do? And it doesn't look like it, so I'll just go ahead and multiply across. My denominator is going to be 35, and 26 times 3, let's see, 18, 6, 7, so 70, negative 78/35 is the improper fraction. And then to rewrite that, 35 goes into 78 two whole times, because 2 times 35 is 70. And I'll have 8 left over. And then my denominator stays 35. And here I have a negative divided by a positive. So that is going to be a negative answer. Coming back up here, my sign is negative. And am I close to 2.5? Well, definitely this is, if this were a few more 35ths, then I'd be really close to 2.5. So that's definitely reasonable. That makes sense. And I'm good to go. Let me know if you have questions on example 1 at all. Example 2, we are multiplying decimals. One important piece to remember when multiplying decimals is that in the end, in your product, is where you place your decimal in the correct position. So again, I like to estimate. So my estimate, 2.5 is about 3 times 3.6 is about 4. 3 times 4 is about 12. And then my signs, I have a negative times a positive, so that's going to give me a negative answer. So I should be around negative 12. I'll probably be less than that since I rounded both of these up. All right, let's do a little math here. 2.5 times 3.6. Again, I'm lining up the digits, but my decimals just happen to line up here. I didn't on purpose line them up. I only line up my decimals when I'm adding or subtracting. Here I lined up the digits. 6 times 5 would give me 30. Carry the 3. 12, 13, 14, 15. Placeholder 15. Carry my 1. 6, 7. All right, so when I add those, it would be 0, 0, carry 1, 9. So I get 9, 0, 0. And then in the end, I need to move my decimal 2 places. Because you have to add the 1 here plus the 1 decimal place here for a total of 2 decimal places in the end. So that would be 9.00 or 9. And it needs to be negative. Okay. All right. Let's try one more example here before you do a few Oyos. And this one wants us to multiply more than 2. So you can see here we're multiplying 3 rational numbers to start off with here. Okay. So let's try that out to see what we kind of come up with here. Okay. Let's do our brackets first. So I have 4/5 times negative 7 over 1. Okay. When I do that, I get negative 28/5. And then I need to multiply that by, negative 1/7. Okay. I can definitely simplify here first. Divide by 7 on top and bottom, I get 1/4. 1 and a 4. And then 4 times 1 would give me 4. And look at here, they're the same sign, so it's going to give me a positive result. And 5 times 1 is 5. So I end up at 4/5. Okay. That's kind of the one way to go about it. The other way that you can do this problem that some of you might like, or maybe you saw this, is remember that when you're multiplying, the order in which you multiply doesn't matter. It gives you the same answer. So what some people might have done, or another idea that you could do, is you could change the order of this around a little bit. So you could say that, you know that 1/7 times 7, well, what do you notice about 1/7 times 7 over 1? Well, these are reciprocals of each other. You'd get 7 over 7, which is 1. And then what's 1 times 4/5? Well, that's just 4/5. So kind of another way to think about that or to do that problem. Alrighty, there are 6 different on your owns here to practice. Please pause the video now, make sure that you're taking your time and showing your work and going through these. And then I will be right back with your answers to see if you're doing them right. Alrighty, the answers to the on your owns. 1 is 2 and 2/5. Number 2 is negative 1/8. Number 3 is negative 9 and 18/100. Number 4 is 3 and 78/100. Number 5, negative 7 and 7/8. And lastly, for number 6, you should come up with 72. Another one of those problems where you could do a little bit of mental math first, rather than multiplying those decimals, lining it up, and doing it the old-fashioned way. Let me know if you have any questions on any of these. And then lastly, we'll do this example 4 with the one OYO here as well. It says an investor owns stocks A, B, and C. What is the mean change in the value of stocks? Mean would be average. Okay, and we're looking at the mean change. So we'll be looking at our last category here. To find the average, we add up our data points, or here are 3 stocks, and then we divide by how many there are. So we divide by 3. So let's find the mean. Negative 180 and 39 cents plus 127.28 plus negative 280, 52, and we need to divide that by 3. Okay. When you add those top numbers together, you should arrive at negative $333.63. And if we divide that by 3, we'll arrive at negative, right? Positive divided by, or negative divided by positive, different signs. $111.21. So our mean change, is negative. So we're averaging a loss, which is not good when it comes to money. All right. Go ahead and pause here to try number 7. Okay. Number 7 said the change in the value of stock D is $568.23. So it brings it up quite a bit. Then what's the mean change in the value of the 4 stocks? So you're adding this in for number 7. Once you add this to your data and divide by 4, then your mean change would now be positive. It'd be $58.65. So please let me know if you have a question on how to do that one or any of the other ones. I would say this section is very, very similar to the section in chapter 11, or in 1 if you're in 7th grade math, where you talked about integer rules. And make sure you're following these rules of same sign. When you're multiplying or dividing, it's a positive, or different signs, so positive and a negative. When you're dividing or multiplying, it's a negative answer. And then you just have to remember those rational number rules, like how to divide fractions and divide decimals, and multiply fractions and multiply decimals, and all that fun stuff. Thanks for checking out this video. I'll see you guys next time.